Everybody, welcome to our January webinar. I'm here with a dear friend, Martine Rothblatt. Martine, a pleasure to be with you again.
Thanks, Peter.
Yeah.
Happy to see you.
Yeah, we go back, God knows, it's been a while, 30 years?
Something like that.
Yeah, 25 years, amazing. And we're gonna be talking about moonshots. And when I think about moonshots, I think about Dr. Martine Rothblatt. Martine, I think if I had to count, you're somewhere between 5 and 7 moonshots in on all the things that you've been doing across a number of different industries, and such congratulations for all that you've done.
Well, thanks, Peter. It's so much fun working on these new technologies, and thank you for inspiring me and everybody else.
You've done.
Well, thanks, Peter. It's so much fun working on these new technologies, and thank you for inspiring me and everybody.
Let me do a proper introduction and read a bio just to give you a sense of the extraordinary person that she is. So Dr. Martine Rothblatt is the chairman and CEO of United Therapeutics, a company started to save the life of one of your daughters.
Yes, who you know, Genesis. Yes.
Yeah, absolutely, who's an amazing person. Martine led efforts to create novel therapies in rare diseases, to decode the pharmacogenomics properties of medicines, to manufacture an unlimited supply of transplantable organs, again, one of your moonshots. She previously created and led Sirius XM as its chairman and CEO, and launched other satellite systems and navigation, international TV broadcasting, and that's of course where you and I first started our friendship, was in your space days. We're both fellow space cadets.
Students for the exploration and development of space.
Absolutely, and I remember the long conversations we had about mining the moon and how does humanity become a multi-planet species.
I was so happy to find a kindred spirit.
Yeah, and it's interesting, from space to medicine. You also hold a Guinness Book of World Records in electric VTOL flight.
Yes,
and we'll
vertical
talk about
takeoff and landing. Yep.
Yeah, vertical. Yeah, takeoff.
Longest electric-powered VTOL flight.
Didn't come from Boeing, didn't come from Bell Helicopter, it came from Martine.
As Margaret Mead said, you know, it only takes a small group of committed people to change the world. Nothing else ever does.
Amazing. Dr. Rothblatt also led the first efforts to create transgender health law standards and to protect privacy and autonomy rights in genetic information via an international treaty. Amazing work.
Thank you. Thank you. I had to put my law degree to use somehow.
It's like my mom saying I have to put my medical degree to use sometime. She has a bachelor's of communications, summa cum laude, a JD, an MBA from UCLA, a PhD in medical ethics from the Royal London School of Medicine and Dentistry, a 6-pack of degrees.
Oh, yes. But they're all fun. You know, you have to love learning because learning is so cool. We live in a time of a renaissance of knowledge where the amount of things to know is doubling like every few years. So not to want to swim in that ocean would be crazy.
Yeah. And we have many, many mutual friends, from Ray Kurzweil to Tony Robbins. We live in a world of incredible people. And I think part of the conversation I want to have with you, Martine, is to encourage people to dream the biggest dreams they can.
Because this is the one time in human history when they can be achieved.
Yeah, yeah. It's never been, it used to be you'd have to be born into the right family or be running the right company or country. Today, the powers of an individual are extraordinary.
We can construct the reality we want.
Yeah, we can, and let's dive into that. So, for our audience, let's define a couple of terms. I talk about this at Abundance 360 in our Abundance Digital community. The first term I want to define is what we call, it's a purpose, in my definition, that is massive, it's transformative, it's meaningful in your life, and it's not just, you know, a local mission or the idea of the day. It's something that drives you. There's an emotional energy component of that MTP. If I were to ask you, you know, and I tell a lot of the people who I mentor, you can start with one, you can add others over your lifetime, but you know, get one focused and build on that. And you had many. Do you mind sharing with me sort of what your massively transformative purposes are or have been?
Sure, Peter. I think my first MTP was to unite the world with satellite communications. And there was a point in time, around the time that we met, that satellites only connected particular countries within the country. There was no such thing as Sirius XM radio. There was no such thing as global satellite internet or international television broadcasting. And I felt that really going back to an inspiration I received from you, Peter, you were very good friends with Arthur C. Clarke.
Yeah.
And you went to visit Arthur C. Clarke in Sri Lanka. And Arthur C. Clarke was the inventor, the discoverer of the basic concept of geostationary satellite communications in a famous article that he published in Wireless World during the 1940s.
Yes.
And he said that that satellites have the potential to be the nervous system of mankind. And that stuck in my mind. And so you were somebody who brought Arthur C. Clarke's ideas here to the US. I sat in audiences when you did live video conferencing with Arthur C. Clarke.
That was amazing. I remember those days.
And I began going to bed each night saying, if it's the last thing I'm going to do in my entire life, I'm going to connect the world with satellite communications. People said it's impossible, it costs hundreds of millions of dollars, it's illegal, there are laws prohibiting countries broadcasting satellite information into other countries. By the way, that's called propaganda, it's against international law. But because I had that MTP inspired by Arthur C. Clarke, I didn't care what the laws were, I didn't care what the limits were, I was going to smash them all down. And it just gives me immense joy now to know that there are hundreds of millions of people who listen to our satellite communication signals. I've been hugged by women in remote villages who said if it wasn't for the Sirius radio station, that they would go mad, that they would have no access to information. I've met kids from villages in India who were able to pass their Cambridge exams and go on to higher universities because of receiving knowledge from our Asia Space satellite that's positioned over India and provides teleeducation. So that the ability to do so much good is what powered my MTP. The logic that it made sense, which I found from Arthur C. Clarke, and I only knew about thanks to you.
Thank you.
That made me think, okay, this isn't just something good, it's something practical. And that combination of passion, like with the cross product of practicality, that's what powered my MTP to make that happen.
Amazing. And from there, and let me take a second and define another term for our conversation here. Again, if you're a member of our Abundance Digital community, you're clear about this. But within the realm of your MTP, which is this broad canvas, if you would, that we're painting on, being able to pick a very clear, specific target to shoot for that is 10x bigger than what you think you can do is considered to some degree crazy by others. Otherwise, it wouldn't be a moonshot. But to have clarity in identifying a moonshot of this by this date, defined in whatever parameters, I think as humans, we do our best work when we're shooting for a very clear, measurable target.
Absolutely. And an example of that is, for example, SiriusXM.
Yeah.
So my idea was I'm going to broadcast dozens of channels of content which people cannot get any other way into every single city in America. But at the time it was illegal. It was like written in the Code of Federal Regulations and the US title that no company can control radio or television stations in more than 10 cities. So that was all because the only television stations were land-based broadcasters.
Sure.
So I was going to kind of 10x blow that away. I was going to go from 10 cities to 100 cities. In fact, to every single town and city in the whole country. And people said it's illegal, and it was illegal.
Yeah.
But those laws were not written with satellite communications in mind. And I was inspired by another role model of mine, Renee Anselmo, who was the founder of PanAmSat,
Sure.
to say that truth and technology will always surpass bullshit and bureaucracy. And to me, the rule that you could not own television stations in more than 10 cities, that was bullshit and bureaucracy.
Do you remember Renee's logo?
Yeah, the dog, spot the dog peeing.
Yes.
So that's an example. Like if I was to say, well, I'm going to try to provide broadcasting across the eastern seaboard, that would be nice, but that's not like a 10x blow up. Say you're going to provide it to every nook and cranny throughout all of North America, that's a 10x blow up. And I think you're right to inspire people to go to something that's targetable, but meaningful.
Yeah.
And I knew all I had to do was one, build a powerful enough satellite that could send its signals throughout the country. Two, get FCC permission to launch that satellite. So it was a very narrow, focused goal. And I went to the FCC and I said, it is impossible for a satellite to be only broadcast to 10 cities. It's technologically impossible. Yet, shouldn't the people that live in Des Moines, Iowa have as much choice of content as the people who live in New York City? Well, it's like a no-brainer. Of course they should. So I knew I won before I even won. I had to actually launch the satellite and win. But when you're right, when you have your massively transformative purpose, I would say you know you're going to win before you actually win.
Amazing. And I think one of the takeaways from me that I want people to hear is the laws are typically written for the historic players, not for the future players. It was written by them to protect them, and a lot of times they will use laws as if you would, taxi fleets versus Uber to keep their dominance. But of course, laws are always evolving, and are you bold enough, like you have been many times over, to say, the laws are not for the betterment of the entirety of society, and we're going to change those laws. Yeah.
Yeah, it was Thomas Jefferson who said, sticking with the laws of your ancestors, makes as much sense as wearing the clothes that you were wearing as a kid when you're an adult. You outgrow them, and we've outgrown the silly laws of our great-grandparents and whatnot.
Yeah, in fact, this is the 100th anniversary of the Women's Rights Amendment of Congress, right? Laws are constantly being changed. But let's turn to what is perhaps the epic story for which you have the world's gratitude and extraordinary respect, which starts a couple of years after XM and Sirius with the diagnosis of your daughter.
Yeah, it came out of right field, Peter. It was like kind of a black swan in my life, that suddenly we're all very healthy, we're skiing at Telluride, and our youngest daughter can't get out of the condo, and her lips start turning blue, she starts fainting, and she's diagnosed with an incurable fatal illness, primary pulmonary hypertension.
How old is she at the time?
She's 10. So it was devastating. I said to the doctor, surely there must be a cure. No. There's a treatment? No. I'm going to get a second opinion. I got a second opinion. It was the same as the first. I began doing research. All the research confirmed what her doctor said. So it was either I do something about this or my daughter was going to die.
And your wife, Bina, you are both looking at each other.
Crying.
Yeah.
We're crying because anybody that's a parent knows that, it's the most natural thing of a human to want to do anything for your children.
Yeah, of course.
So, but after the crying, there was then the reality that there was a clock ticking. We had.
How long is this? How long is this clock now? Because it's your daughter's life on the line. She's 10.
The doctor told us, who was the head of Roger Ruckman, the head of pediatric cardiology at Children's National Medical Center in Washington, D.C. So we were at the. I was successful, so I wasn't going to go to the Minute Clinic at Friday or CVS, wherever. I mean, we were at the pinnacle of medical knowledge, and this guy said every kid I had with this disease died. So it was either like I do something myself or nothing was going to get done. He said that she had between 2 to 5 years.
Wow. And so there's an interesting point in a human being where you either accept it fatalistically or you say, damn it, I absolutely refuse to let this be what happens. And you chose the latter, and what understanding what you did, I'd like to dive into your mindset here, because that's the important thing. What's going on in your mind, and how do you, because you have to be thinking at this time that here's the pinnacle of modern medicine, all of these experts, if they could have cured it, they would have cured it. But in that face of that kind of fatalistic, deterministic future, how do you say no? I, a lawyer, an entrepreneur, having no biomedical background, I'm going to do something about this. What was going on?
Yeah, Peter, it's an insightful question you ask, because I have to admit, now that I hear your question, that what I said just before is not always the case. I did not know I would win before I won with Genesis and coming up with saving her life with the medicines. And it was because I think things happened so quickly. I had no biomedical knowledge background. The whole body was like a black box to me. And what I said to myself was that I have to do everything in my human power to save Genesis. I have to teach myself whatever I have to know. I have to spend every dollar that I have. I have to work 24 hours a day. And if at the end of the day I can't save her, so be it. But until we get to that point, I'm going to do everything I possibly can do to save her.
And you have to know in your heart and your mind that you've done everything possible.
Yes.
So do you, at that point, you were still at Sirius?
Yep.
You're still at Sirius. You stepped down?
Yes, I stepped down. I told everybody I have a personal family emergency. I have to devote all of my attention to this. They said, well, you could stay part-time in this. I said, no, I have to work on this 24 hours a day. This is not like a part-time job, saving Genesis. And
by the way, can I pause on that moment? Because I think that is a really critical distinction that I want to make for our community here, which is the choice to be so emotionally passionate and invested that everything else is gone, that this becomes everything.
It's what you said before, focus. The key attribute of an entrepreneur is to be able to focus, to twist that, focus lens on your camera, and everything else fades to a blur, and you're just targeting in on what you have to do. I had to cure Genesis.
Yeah.
Nothing else mattered. Sleep didn't matter. Nothing mattered.
Yeah. And so I think that distinguishing feature of that level of passion and dedication, I don't think people realize they need to do that.
You do. I said to myself for like the second time in my life, I said, if this is the last thing I do while I'm alive, this is what I'm going to do. I'm going to do everything I can to save her. And I said to myself, I will save her.
Yeah.
There was a question mark in my mind if I could save her, but I said to myself, I will save her.
Yeah, and that again, that's another psychological twist that's critical, right? Like, I can, somewhere, somehow, someplace, there is a solution.
There is a solution.
Right? And for me, my equivalent was, I'm going to fund this X Prize, the first Ansari X Prize, after 150 no's, just deterministically, somewhere, someplace, someone will do this. So you step down, you're 100% focused, but you have zero biology background, zero medicine background. Tell us that story, please.
But I know how to read.
You know? And you're an intelligent human being.
So, and there are books on biology and physiology and anatomy and biochemistry. So I just began reading these books, one after another. I would first I would research the word pulmonary hypertension, which was her disease. And I read the articles on that. There were no more than 50 articles because
Wow.
It's a rare orphan disease. That's why nobody was working on a cure for it. But I remembered from law school that every case cites the cases it depends upon. Every scientific journal article cites the other articles. So I looked at all the articles that were cited in those 50 cases, and I read those articles. Much of what was in those articles was gobbledygook to me because I wasn't trained in biology.
Sure.
So then I went and got a basic biology book, and whenever there was a word I didn't know, I looked it up. And I kept going back and forth from the advanced peer review articles to the college textbooks, even to high school level textbooks. You can even go back to something like Biology for Dummies, okay, and get your basis, and then just go back and forth until before you know it, you are an expert. And I will say that, there is nobody that cannot become an expert on any subject on this planet. Everybody has the potential to be an expert on whatever it is that they want to be an expert on. That's why we're so lucky to live right now. You don't even need a library anymore. All you need is a smartphone.
And on top of that, your ability to reach experts almost any place on the planet is now, infinitely better than it used to be.
Exactly, but at first, I would come in and I would try to get appointments, and doctors would say, "Well, it's very nice to meet you and talk with you, but you are an expert in satellite communications. You don't know what you're talking about." And I had my ideas. I said, "Why don't we try this kind of medicine? Why don't we try this kind of treatment?" And people were very, very condescending, Peter, in the medical profession.
Yeah.
I think that I had to break through that. But I didn't take no for an answer, and it was fortunate that I had resources from taking SiriusXM public.
Sure.
So I applied those resources, and I kept moving forward. I built up a team of other people who were filled in gaps in my knowledge, and I used as force extenders. And finally, I had a drug in clinical trials, and it proved effective in treating pulmonary hypertension.
So how long from diagnosis to getting that drug? What's the time frame here? 'Cause you have a clock ticking down.
Yep. So it was 2 years from diagnosis until getting the drug into clinical trials, 5 years until getting it approved by the FDA.
And how long was Genesis in that early clinical trial?
She was not in the clinical trial because the FDA rules make it virtually impossible to put a pediatric person in a clinical trial.
That must have been so difficult to have this potential cure there and not being able to give it to your daughter.
It had to be, to get FDA approval, you have to do the trial as a placebo-controlled, double-blinded trial.
Yeah.
So even if she was in the trial, I wouldn't have had any ability to assure that she was in the active group. You have to play things by the rules, as always in life.
Yeah, of course.
And my main adage is that, yes, I'm a passionate entrepreneur and a passionate technologist. Yes, I'm highly focused, and I talk about not letting any, laws or walls get in my way, but you also have to play by the rules. There are rules for changing the laws, and when I say don't let laws get in your way, that doesn't mean to break the laws, that means to change the laws.
Yeah.
And when I say don't let walls get in your way, that doesn't mean to drive off a cliff and kill yourself. It means to remove the walls and put the walls somewhere else.
Yeah. I mean, all of these are, would you agree, the severity and the difficulty that you had is extraordinary. And again, your daughter is such a beautiful person that it's a shining light for the world.
It's not just her now, it's tens of thousands of people. There's a whole football stadium of people who are alive today that otherwise wouldn't be. When she was diagnosed, there were only 2,000 people in the whole US who were diagnosed who were living with this condition.
Because they died early.
Because they all died.
Yeah.
It's something that just has a regular incidence in the population, and the prevalence is very low because they all died. Now, because they don't all die, there are 40,000 people in the US living with this condition, taking our medicines.
Yeah.
That's a whole stadium of people who are alive.
So
beautiful people who have gone on to have children, to run for mayor, snowboard champions, you name it, all different walks of life.
A real tribute to you, Martine. Congratulations. The courage to do that. How did you, during the early days there, talk about the courage to take on a moonshot, and where do you find that courage?
So for United Therapeutics, I found the courage in saving Genesis. Yeah. I felt that I just defined my life's purpose as saving her. Previously, I found the purpose of my life in trying to unite the world with satellite communications, hopefully to take us back from the abyss. And I said, I just defined for myself that the purpose of my life is to unite the world with satellite communications. Today, I've defined the purpose of my life as producing an unlimited supply of transplantable organs.
I love that.
And we've already made huge progress. We've saved over 1,500 people with manufactured organs, something that people thought was absolutely impossible. But we've got a long way to go, and I've just defined my life as this is the purpose of my life.
So let me slow this down a little bit for our audience here. United Therapeutics is formed as a result of the drug that you brought through clinical trials and successfully used.
Which I didn't do it for money. I could have cared less about
Right.
money. I had more than enough from SiriusXM. But it is a fact that the drug sells for over $1.5 billion
And
of revenue
United
a year.
Therapeutics is a $5-6
Multi-billion.
billion company right now, which and I love the vision of. And besides that drug, you took a much broader moonshot now, and a moonshot of as you said, being able to provide an unlimited supply of organs. Which organs? Where are you starting? What's the
Lungs,
vision?
hearts, kidneys. So those are the 3 organs that we're working on. Already we are saving lives with manufactured lungs. We have are almost on the cusp of starting clinical trials for manufactured kidneys and manufactured hearts. We have all of the world's records for keeping baboons alive for months after months after months, actually 3 years with hearts, a year with kidneys, with the manufactured kidneys, and the FDA requires us to first test those in baboons before starting clinical trials. So this is something that I absolutely believe, Peter, that we will be able to achieve and accomplish. It's practical. I have an enormous passion for doing it because I have met so many people, beautiful, kids, teenagers, and senior citizens who, but for lack of a manufactured organ, die prematurely.
So in the future, you'll never die from a lack of an organ.
You won't. And people will think it's, Peter, the richest man in the world in the 19th century was a Rothschild who died from an infection that today can be cured for a 2-cent penicillin pill.
Sure.
Okay? And so the poorest people in the world today don't die from what 150 years ago the richest person in the world died from. And it will be the same thing at the end of this century. People will be astonished that just because their kidney or their heart or their lung gave out, that's like, okay, game over, your organ's like, well, why didn't you replace the organ? If you lose like a tire on your car, you're not going to trash the car, you're going to go buy another tire.
And what I love about you as an entrepreneur, a scientist, and an engineer, Martine, is when you said, let's focus on lungs for a second, I'm not going to just have, go on just one direction. You've actually pursued manufacture of replacement lungs in a multitude of directions. How many total are there, if you just enumerate them for me?
Sure. So we've got 5 parallel pathways, and I think as an entrepreneur, it's really, really important not to put all of your eggs in one basket, because life is inherently uncertain. Mm-hmm. One of my favorite books is Talib's book, The Black Swan. I mentioned, Black Swan earlier in the conversation. And, the take-home message from that book is that life is uncertain. And the best way to deal with that uncertainty is to have multiple different pathways underway. So if, say, a black swan event occurs and knocks out 1 or 2 of your pathways, you've still got 3 other pathways. Like in simplistic methods of financial management, you don't want to put all of your wealth in equities or all of your wealth in fixed income, because a black swan event may occur that knocks out one or the other asset class. So you hedge your bets in different asset classes. In organ manufacturing, we've got 5 different pathways that we pursue. The first is to take dead organs that are not usable for transplantation, but were once in a human body, and bring those organs back to life by building an artificial body that can, over a period of many hours with special biological solutions, bring an otherwise dead organ back to life.
And you call that one the ex vivo?
Ex vivo perfusion, because it is taking something outside the body.
And that's up and operational?
That's up and operational. That's saved over 1,500 lives already.
Amazing.
I met this lady just on September 21st. We inaugurated one of our other moonshots. I said, why can we not build a 100,000 square foot building that has a 0 carbon footprint? Well, nobody had ever done that before. People built small buildings with a 0 carbon footprint. People had built 10,000, 20,000 square foot buildings in temperate climates like San Diego with a 0 carbon footprint. Nobody had ever built a 100,000 square foot building with a 0 carbon footprint in a cold climate like the US Northeast. I did all the math. I knew it was practical. Turned out we built a 140,000 square foot building, the largest in the world, which is our company's headquarters now in Silver Spring, Maryland.
What do you call it?
We call it the Unisphere.
Right.
And so for the grand opening of the Unisphere, which we did this past autumnal equinox, the day of the year when the sun, daylight and evening are evenly matched, we invited one of the ladies who received our manufactured lungs in this fashion. She's only 30 years old. She was in college, she was a star shot putter. Then she developed pulmonary hypertension, just like my daughter, had a very, very aggressive case of it, blew through our medicines, were not able to slow down the disease.
Wow.
She was on the transplant list. The doctor said she's not going to be able to get an organ in time before she dies. And they asked her, would you like to try one of these experimental manufactured lungs? And she said, what's my other alternative? They said, you're going to die. She said, I'll take them. We gave her two, a matched set of lungs. Many people just need one lung, but we gave her two of our manufactured lungs at the beginning of 2018. By the middle of the year, she had not only recovered, she participated in the U.S. Transplant Games and won the gold medal in the shot put at the U.S. Transplant Games.
Amazing.
So that shows you what manufactured lungs can do. And those were things that were in the trash can. Nobody wanted them.
Wow. And just to take 1 second and explain, I mean, what percentage of lungs that
80% are thrown away.
Yeah, I'm an organ donor.
Thank you.
And
Thank you
of
for
course,
doing that.
I think it's the most logical thing to do, and I beseech all of
Unfortunately,
you.
99% of people, they die in a way that their organs are not transplantable. Of the 1% who die in a way which is called a brain dead donor, whose organs are transplantable, amazingly, 80% of those lungs are thrown away. Because
Why?
by the time that the kidneys and the liver are removed, the body's fluids have rushed into the dead lungs and filled it with mucus and fluid that makes it completely unusable to put into a person in an intensive care ward who's dying of end-stage lung disease.
And then your ex vivo perfusion machine.
We suck all the fluids out of it, we suck the mucus out of it, we fix any tears, we stabilize the lung, and we let the surgeon see it in real time with real-time high-speed network we created that let them see bronchoscopy and x-ray images down all the different parts of the lung in real time.
So you're like a used car salesman. Check it out,
Yeah.
all the parts are working.
If you don't like it, and actually, I've also undertook at our own expense. Unfortunately, money is a factor in healthcare.
Yes.
And United Therapeutics says, if you do not want to use these lungs, we'll cover all the costs it took to take it to you. We'll just eat those costs. Despite that, Peter, every single time a transplant surgeon has taken these lungs, 100% of the time they've been transplanted, and 100% of the time those patients have left the hospital healthy again.
Thank you, Martine.
So
That's beautiful.
So, life can be beautiful. Life can be beautiful. And I said to Heather Leverington, this lady who was the shot put champion, I said, nobody to me in 2018 represents how beautiful life can be than you, Heather. And that video is on YouTube. You can find it. But the other ways that we do this.
So that was number one. Number two.
So another way is, Americans eat 100 million pigs a year, all the different parts of the pig. But through a fluke of nature, of all the animals in the animal kingdom, the animal whose organs are the closest size match to humans, even more so than chimpanzees and baboons, is the pig.
Wow.
And many people are aware of this because they're aware that if people need a heart valve, the heart valve which is used is the pig's heart valve.
Sure.
Because it's the exact same fit, and a valve has to fit right or else it's no good at all. So it's remarkable just the way evolution worked out that way. So I said, well, why can't we take the knowledge of genetic engineering, which has developed over the past 20 years, and engineer out of the pig genome those proteins that give rise to rejection of the pig's organs inside the human body, and engineer into the pig genome genes that will humanize the pig's organs so that to the human body they will look like a human organ.
And is this using CRISPR technology?
It is using CRISPR technology,
Right.
totally.
Yeah.
And we are now the world's largest cloners of pigs. We actually have more pigs in our company than our 1,000 employees. They're at a very nice farm, spelled P-H-A-R-M, out on the outskirts of Blacksburg, Virginia, near Virginia Tech. And these organs are shipped to university hospitals all over the country and even the world. So this is our second pathway to create an unlimited. We would need, by the way, only 1 million of those 100 million pigs a year that are eaten in the US. 1 million of those pigs used as organ donors would completely eliminate all death from end-stage organ disease.
Wow, that's amazing. So how difficult is it to actually use CRISPR to humanize a pig, and where in that process is it? When do you think we'll get there?
Yeah, it's not easy. Editing genes is kind of easy. Editing the right genes is difficult. We delude ourselves thinking that there's only 20,000 or 30,000 genes to work with, but each gene has, hundreds of different polymorphisms,
yeah, sure.
and control sequences,
Yeah.
as you said. So it's a complicated thing, but fortunately what we did is we sequenced the pig's genome to a higher level than anybody else had done. And I would say in United Therapeutics, we know the pig's genome better than anybody else. We have a world-class gene editing and cloning team. So my hypothesis was that it would not take hundreds of genes to modify the pig genome to be compatible with humans. It would only take like anywhere between 8 to 20, something like that. And it's turned out to be about 10 or so genes is all that's needed in order to make the body tolerate a porcine organ as well as it would tolerate an organ from another person.
Sure.
And then we can rely on immunosuppressants to do the rest of the job. So I'm entirely confident, Peter, as confident as I was with launching SiriusXM,
Sure.
that we will have in the early 2020s, the next 5 years, the first clinical trials of people with what are called xenokidneys. That's a kidney that comes from a genetically modified pig, a xenoheart, a heart that comes from a genetically modified pig in the early 2020s. We've got additional pathways as well, though. I don't want to put all my eggs in that basket, even though it's a good basket.
So the third approach now?
The third approach is we start with a pig's organ, but we strip all living things off of that pig's organ, all the living cells off of the organ. So all you have is the framework of the organ, what we call the scaffold of the organ. The scaffold is made of collagen and has no immunogenicity to it. There's nothing that reacts in the human body and the human immune system to the collagen, which is just a protein.
Sure.
And then we cellularize that scaffold with human cells so that instead of giving the body something to reject, it's really no different than if like somebody like you who's an organ donor gave an organ to this individual, but it was a human organ that we manufactured in the bioreactors in our labs.
And would you try and use that individual stem cells to originate? Would you go and where are you? Do you have a cell? What cells are you using to help cellularize?
So ultimately, we are going to use that individual cells, and that's like the fourth track is using inducible pluripotent stem cells to expand those iPSCs until we have enough of them to completely cellularize the organ. Then the individual will not require any immunosuppressants at all. I think we'll be doing that in the second half of the 2020s, but we are able to commercially purchase allogenic cell lines, people who donate blood and people who donate their bodies to science. Those cell lines are available for purchase. They're not enough to cellularize an organ. What we've developed in our company is what's called cell expansion technology. We can start with 10 million cells, which we can purchase, and we can expand them to 10 billion cells using 3D expansion chambers.
And how many cells do you need to cellularize a lung?
About 10 billion per the lung, the heart, each one of these needs about 10 billion cells.
It's hard.
And we're doing that now.
Yeah, it's interesting, right? Because we as humans are a collection of some 30 trillion cells. People don't think about that.
So we'll have these, what I call allogenically, meaning coming from people, recellularized porcine scaffolds in human clinical trials in the same time frame as the xenokidneys, xenohearts, and xenolung.
And there's one more approach that you're working on.
Yeah, the third approach is actually my favorite, Peter.
Okay.
And we are using tobacco leaves from tobacco plants that have been genetically modified to express human collagen in their tobacco leaves. and then we digest those tobacco leaves and we extract the human collagen. Then working with 3D Systems, one of the main partners of X Prize Foundation,
sure.
we then print the scaffolds for the lung, the kidney, and the heart using this 3D printed, using this tobacco-derived human collagen. So there's no animal product involved at all. There's no need to decellularize and recellularize the porcine scaffolds. Instead, we 3D print the scaffold using this recombinant human collagen grown in tobacco plants, and then cellularize those scaffolds with the individual's own cells.
Amazing. And you've actually done that. You've started the branching.
We've done 4 branches so far. We've got a typical in the lung, you have something like 18 branches.
Yeah.
So we've got more ways to go, but we have a disciplined engineering approach. Basically, every year we are doubling the number of branches that we've 3D printed with this human collagen. Nobody else had ever grown human collagen or used it like this, and it's an amazing technology. The beauty of this, by the way, is if it's like a little kid, even a neonate, we could print a lung that's just the right size, or a heart or a kidney for people of any size.
And then you still have to recellularize those with stem cells.
We still have to recellularize them with stem cells.
And what, just to take that one level deeper, what's the challenges you have to do that? Because, I mean, do the stem cells differentiate and structurally define themselves based on the collagen there? How do you bring in blood vessels? What's going on there?
So they form the blood vessels. You know, the stem cells are remarkably smart. In fact, all of the cells are really, really smart. So right now, we do day in, day out. In fact, we do over 500 recellularizations a year right now. So we use the porcine scaffold. Okay, the porcine scaffold is no different than the 3D printed scaffold. It's just a scaffold. And it's got this it's almost like a spider web if you look at it. And as we begin gradually streaming cells into it, they lie down. In fact, I tell people cells are smarter than people, because when one car stops on the freeway, even on the side of the road, like everybody else stops and you have a giant clot, you know, that we're stuck in for hours. Thank goodness we have Sirius XM. We have something to entertain us while we're stuck. But the cells are very smart. When the first cell lies down and stops, the next cell that we push behind it, it rolls over that cell and it lays down where it sees that there is no cell. And they each go to a place where there is no cell. The cells are smart, are very, very smart. But here, Peter, you see the beauty of avoiding black swans by having multiple parallel approaches to achieve your goal. Because by already recellularizing the porcine scaffold, I'm developing the exact same technology I need to recellularize the 3D printed scaffold.
Which leads us to your next moonshot.
My next moonshot is for all of these organs to be delivered by totally green vertical takeoff and landing, or what I call eviation. Eviation instead of aviation. And I do have a passion for saving the earth. I think this is like the most amazing place in the universe. I think anybody would obviously think that, not just because we live here, but we haven't seen any place that, like, you know, is vaguely as cool as this place, And so I definitely want to preserve it. I've got children and grandchildren. I want to make sure that they have a good life, and all the other billions of people. So aviation right now is about 5% of global warming due to carbon output, and is scheduled to rise to 9%. I think we can eliminate that completely with eviation. And we're developing a fleet of electrically powered vertical takeoff and landing aircraft that will fly autonomously and be able to be loaded with organs at our points of manufacturing, fly to designated hospitals. The staff at the hospital would retrieve the organs, and then the aircraft would fly on to its next destination or back to the point of manufacturing.
So in the future, your vision is it's going to be electric transportation?
Yes. The biggest difference, if you come back like in 50 years and someone says, like, what is like probably the biggest difference that you'll see? The biggest difference is 50 years from now, the skies are going to be full of flying things. And people are going to say, these stupid flatlanders, they have a whole Z dimension, but instead they're just deciding to keep on the XY plane. Yeah, they'll throw like an arrow through the Z dimension or, here and there in a commercial airliner, but they're basically flatlanders on the XY plane. But the next several decades, we're going to take over the Z dimension, and it's going to cause an exponential growth in the productivity of humanity.
Yeah. So when do you think we're going to start to see people like you and I, actually you're a helicopter pilot, I'm a pilot, but commuting in electric vehicles from point to point?
Oh, totally within the 2020s. I mean,
Yeah.
it's going to happen. Already the FAA is laying out the rules to allow that. The largest corporations in moving people from place to place, Uber and Didi in China, are investing heavily in electric vertical takeoff and landing. Boeing, Airbus, every major company is now moving into this area. So if the writing is ridiculously on the wall that vertiports will be built everywhere, there will be about as many vertiports as Starbucks. And people wondered, like, well, how could you have like a Starbucks on every corner? Well, we do, right? And there will be vertiports everywhere, and it will just be, that's the way we'll travel.
Amazing. So in this region of electric transportation, aviation as you define it, that's your latest, if you would, passion, MTP.
Yes.
Did you set a specific moonshot of a target that you wanted to achieve with the concrete numbers?
Yes. My specific, I actually, as won't surprise you, I set several.
Okay, good. I mean, and how important is it, do you think, as an entrepreneur and someone developing moonshots to set very concrete goals?
It's crucial.
Yeah.
It's the sine qua non of success. If you fail to plan, you plan to fail. And if you fail to plan practically and realistically, then you are going to very practically and realistically fail. So you've got to have like practical, doable, tangible goals.
Measurable.
Yeah. So my first goal was to simply demonstrate that you could fly a helicopter under electric power. And people thought that was impossible. We achieved that a couple years ago at Los Alamitos Army Airfield, and that
Using a Robinson 44?
using a Robinson 44. The entire video of that is on YouTube, and I put up a whole explanation of every aspect of the power chain so other people could see exactly how we did it and replicate it. So there's no black magic, Wizard of Oz stuff behind the curtain there. Then my next goal was to achieve the definition of what we call in aviation a cross-country flight, which is 25 nautical miles. We achieved that last year and received the recognition in the Guinness Book of World Records.
Congratulations.
For the longest electric helicopter flight. My next concrete goal is to do a cross-country flight from the East Coast to the West Coast, all by green energy electric aviation. And I feel confident that we're going to achieve that in 2020.
Fantastic.
And then my next goal is to achieve FAA certification for our e-aircraft, so anybody can start buying them and using them. And our goal is to achieve that by 2024.
Wow. And by the way, getting FAA certification for anything is not easy.
It's not easy, but dozens of people have done it.
Yeah.
And there's nobody more passionate than myself and our team. We all are super excited because we feel that like, hey, we're back in like the 1900s and the 1910s when people were inventing aviation, and we get this priceless opportunity to invent aviation again. And we just feel like, we are like, all these really cool people that we look up to as idols from the pioneers of aviation. We get to be the pioneers of aviation.
Yeah, that's fantastic. So, by the way, are there any moonshots that you're thinking about beyond? I'm sure you are. Anything you want to share as sort of like future moonshots?
Well, one moonshot that, Peter, I'm very passionate about is for people not to be given medicines that aren't going to work for them in particular. I think it's kind of absurd that there's an adage in medicine that people see 5 doctors before they get an accurate diagnosis. They try 5 medicines before they find one that works for them. And we're now in the day of, the $100 genome.
Yeah.
And we have enormous big data and AI are the biggest buzzwords. So if you take the $100 genome, big data, and AI, you put that all together, I think what you get is what I call pharmacogenomics.
Sure.
That you're able to basically know exactly which medicine you should have for the exact polymorphisms expressed in your body.
And have you been using AI at all in the helicopter world, in aviation world, or in United Therapeutics?
Not directly, we haven't, Peter, but what we have begun doing, and to my knowledge, I think we're the first pharmaceutical company to do this, is we now sequence at our own expense all the genomes of all the patients in all of our clinical trials.
And which will become the standard, of course.
And I believe we'll be the first company to go to the FDA and say, we want you to put on the label for this medicine that it is works best for people with the following polymorphisms, and then to provide a free opportunity for any physician to take a blood sample from that patient, send it to us, we'll sequence it and tell the physician if the medicine will work for the patient or not. Yeah. So no more kind of, when you were a kid, you played blind man's bluff, you close your eyes and try to bump into somebody. That's kind of medicine today.
It's crazy.
And I think it will be laughable, and hopefully we won't be in the Star Trek mode of Dr. McCoy saying, he feels sorry for people stuck in 20th century medicine. And hopefully 21st century medicine will be a lot better.
Fantastic. Well, let's go ahead and turn to some of your questions now, and I'll ask Brita to read them out loud to us.
Sure, thanks.
So this one's from Nancy. Do you do any biohacking? What are you doing to extend your own life?
I follow the advice that wise people share with me. So I definitely positively do biohacking. I think it's a great thing. There actually is I don't know if it's a website or just a guy's handle, biohacking, but I find actually some of the best information on the web under this guy, at biohacker, biohack.com. If you Google it, it comes up. My friend Peter here gave me a great book about a year ago or a year and a half ago called How Not to Die. And it
great title, huh?
And it was written by this guy, Dr. Greger. What you probably don't know is I've since become friends with Dr. Greger, who lives in Rockville, Maryland, not that far from our headquarters. And I had a delightful dinner with Dr. Greger and my friend Seth Goldman, who's the founder of Honest Tea, and now the founder also of Beyond Burger, Beyond Meat. And so the three of us and our partners all had dinner together. He's very, very funny. So I try to follow the precepts of Dr. Greger.
Beautiful.
Great. Next one's from Eric. Why have you chosen to focus on organs? Was there an event in your life that drew your attention to the organ space?
Yeah, thanks for the question, Eric. The main reason is that the only cure for my daughter's illness is pulmonary hypertension, is an organ transplant, is the only cure for pulmonary hypertension. And our medicines slow down the progression of the disease, and depending on each patient's polymorphisms, it can slow it down a lot or a little. Fortunately, in the case of my daughter, Genesis, it's slowing it down a lot. In the case of Heather Leverington, who I mentioned just before, it slowed it down only very little. So at the end, they need an organ transplant. But there are only 2,000 lungs transplanted each year, but 250,000 people a year die in the US alone of end-stage lung disease.
Oh my God.
So the chance of any one person who needs a lung getting one
right?
is less than 1%. And that huge unmet medical need is what drove me to focus on organ transplantation.
Next one's from Joe. I read about your farm in Virginia in an article last year. Can you describe what it's like today and what you think it will look like in 10 years?
Yeah, thanks, Joe. What it looks like is basically a whole bunch of very sterile trailers. And one of the really good things that BARDA, the Biological Advanced Research and Development Agency, invested in were these kind of turnkey drug development labs that could be dropped into anywhere in the world and produce drugs or other pharmaceutical products under what are called, quote unquote, good manufacturing practices, meaning the output would be something that's safe to put into a person's body. So we have repurposed many of these type of BARDA containers and used it for being able to grow our pigs in a pathogen-free environment, so that when we are able to explant the organs from them, we will not be bringing any new diseases into the patients that would receive them.
This one's from Dan. A lot of people that I talk to say that programs like Uber Elevate will never be successful because of the noise they create. What do you think needs to happen in order for them to be successful?
So I think that probably there were similar comments made about cars will never will never be adopted because of all of their various problems. Planes will never be approved because of the noise they make. I really think that with humanity, convenience trumps everything. If I had to have a book of like 100 adages, one of mine would be nobody ever lost money making things easier for people. So
that's Jeff Bezos, right? Cheaper, easier, more opportunity, more options.
Exactly. Now, having said that, I would like to also mention that our very first eVTOL, the one that is now listed in the Guinness Book of World Records, has a measured decibel level, which is less than half of the decibel level of a regular Robinson R44.
Wow.
And we have additional technologies that we are working on that we believe will bring the decibel level down to a fourth and perhaps even less than that of a conventional helicopter. There's also, if you're familiar with the concepts of like constructive and destructive interference when you're talking about waves, it's possible to have helicopters or eVTOLs kind of cancel out their own noise by using what's so-called destructive interference. So one, I think there are a lot of technologies to greatly minimize the noise. We've already proven that the first eVTOL is much quieter than a conventional reciprocating engine or jet turbine powered helicopter. And secondly, the enormous convenience of these eVTOLs will make them a compelling proposition. Will there be some neighborhoods where eVTOLs are not allowed? I'm sure there will be. But the fact that, 1% or even 10% of the space is not accessible to eVTOLs would not diminish the dominant reality of 90% of the space being accessible to them.
Yeah, I think if I remember correctly, the noise is a function of the sixth power of the tip speed. Mm-hmm. And when you go to electric drives, you go to smaller rotors and multiple rotors.
Exactly. The physics of noise gives a lot of room for creativity.
Yeah.
This is our last one. It's from Sarah. You've led very large and powerful organizations successfully. How would you describe your leadership style?
So Sarah, I personally would not really describe my organizations as large, because typically my organizations are 1,000 people, plus or minus. I think of a large organization as like 100,000 people or 200,000 people. I wouldn't really even know how to run that type of an organization. I try to pay as much attention to Dunbar's number as possible. As you're probably aware, Dunbar's number is a number of, roughly something like 75 to 150 people. It traces back to the size of chimpanzee troops, also the size of platoons in military organizations dating back to Greek and Persian times. It's a number of people that everybody can bump into somebody in the workplace and you know their name, you know what they do, who they are. You feel a camaraderie with them. So I try to organize my teams into Dunbar number size groups, and I ask, I myself define myself as, I tell everybody that for me, CEO means Chief Encouragement Officer. I'm not here to tell people what to do. I'm here to encourage people to be the best that they can be at what they want to do. Of course, we hire people who want to transform organ transplantation, who want to transform aviation. And then my job is just to encourage them along the way, to encourage other team leaders, to encourage other people in their groups. And it's all really about positive energy. I think if you interviewed people at United Therapeutics, SiriusXM, you said to them, you know, what is the main characteristic of this environment? They would say positive energy.
Martine,
We even have, like in our labs down in La Jolla, we have sayings that I didn't tell the people to put up, but they put up on their own, which was, you know, be like a proton, be positive.
Martine, the average human life expectancy has been for our age group, sort of 70s into the early 80s. I'm curious what your thoughts are about what human life expectancy could be and should be for us, for people in their 50s, early 60s, and where is it going?
I think it could be and should be, you know, practically unlimited, and it can be by using technologies that transport you into the future over any abyss that a particular illness or accident may have caused. And those two technologies are called cryonic biostasis and cybernetic biostasis.
And so both of those are technologies that would have a effective near-death experience and then a transformation into ultimately an unlimited life
Correct.
span. In terms of using technologies today, some of the work that's being done by senolytic medicines, by Unity Biosciences, or stem cells, or SAMUMED, or other technologies, for people who are looking for more near-term applications without a discontinuity, if you would, what do you think the human lifespan can get to?
I think it could really be practically unlimited.
Even without cryonics, even without
You know, I tell
uploading.
people all the time, biology is technology. We're a machine. We're an amazing machine. We've never built a machine, you know, 1% as amazing as us, but we're making progress. I'm working with groups now that are doing synthetic chromosomes, that are, you know, creating their own chromosomes, creating their own cells, creating their own life forms. Our tiny company, United Therapeutics, is making the, if you will, kind of the core organs of the body. So if we, in 2018, are manufacturing lungs and hearts and kidneys, how hard of a stretch is it to believe that if other parts of your bodies are failing, that we will have the technology in this century to replace those parts of your body? To me, it's obvious that I think it's really almost funny when people say, "Oh, you know, don't you think there's like a hard limit, like 120 years?" And it reminds me of people, you know, earlier just accepting, like I said, the richest man in the world in the 19th century died from something that the poorest person in the world today routinely cures.
You know, you and I were both together at the Vatican, and we were in a conversation with a group of, I don't know, a few hundred leaders, both religious leaders and science leaders. And I remember asking the question, how many of you would like to live to 120? And shockingly, you know, only a third of the audience raised their hand.
My guess is that that's the third of the audience that had found love in their life.
Huh.
And the missing ingredient, the topic we haven't spoken about, but I know we're kind of out of time, but perhaps the best coda is love. My own personal mantra is to, first of all, to be curious, to act with curiosity. Secondly, to question authority. When someone says something can't be done, to ask, you know, why can't it done? Third is to do practically, like you were talking about today, put near-term goals that you focus on. And most important of all is to act lovingly. And it's this spirit of love where the happiness of the object of your love is essential to your own happiness. That will drive you forever. Love is the ultimate power.
Amazing. And what a beautiful place to wrap us. Martine, on behalf of all who love you, including me, thank you for all that you do.
Thank you, Peter.
Thank you. See you guys. I wish you a fantastic rest of January. Those of you who are Abundance Digital members and Abundance 360 members, we'll see you on the 27th, 28th, 29th in Beverly Hills, live or digitally for 3 days. It's amazing. We're alive in 2019. Can you imagine that? This is 100 years ago, 50 years ago we landed on the moon. 100 years ago, Raymond Ortigue put out his challenge for Charles Lindbergh to fly from New York to Paris. The rate of progress today is shockingly fast, and it's only accelerating. And truly, and you and I have had this conversation, only time better than today is probably tomorrow. Yeah. Take care, everybody, and thank you, Martine.
My pleasure.